Okay, so in Chapter 7, Section 3, we're going to prove triangles are similar using the AA similarity postulate, SAS similarity, and SSS similarity theorems. Okay, so the angle-angle similarity postulate says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all we need to know to say that two triangles are similar is that two angles are congruent. So congruent means that they're exactly the same. Okay, there's the symbol for congruent. So if we have a, let's say, a 30-degree angle and a 70-degree angle in two different triangles. Okay, all triangles have to add up to 180 degrees, so that means that these third angles have to be 80 degrees. And so since all three angles are the same, that we know the two triangles are similar. Okay, but we really just need to know that two angles are congruent. So we're going to determine, are these two triangles similar? And we need to state how we know. So how do you know? Okay, well, we need two angles that are congruent. We see that angle R is congruent to angle V because both are 45 degrees. Okay, I also know that this angle inside here is congruent to this angle over here because they are vertical angles. So angle WSR is congruent to angle BSV. Okay, and I know that they're congruent because they are vertical angles. Okay, so since we have two pairs of congruent angles, yes, the two triangles are similar. Okay, so then I can say, I can go back up here and say that a triangle RSW is similar, not congruent, but similar to triangle VSB. So they may not be exactly the same size, but they're similar. Okay, this one we're going to leave blank for now, and we will come back to it later. Okay, this one, we've got two isosceles triangles, so I'm going to redraw them so that they're right side up, how we're used to seeing them. So here's X, Y, Z with our 68-degree angle here. Okay, so since it's isosceles, that means both of our base angles have to be the same, so this one has to be 68 degrees also. So if we add 68 plus 68, subtract that from 180, we get 44 degrees. So this angle appears 44 degrees. I'm going to redraw the second triangle, A, B, C. A is 62 degrees. Okay, so these two down here have to be the same. So if I take 180, subtract 62, we get 118. So then if we divide that by 2, we know that each of those base angles have to be 59 degrees. Okay, and then, so if we look back at our other triangle, over here, none of these angles match these angles over here, so no, these two triangles are not similar. We have two theorems. The side angle side similarity theorem, so SAS similarity, is similar to the side angle side congruent, except instead of the two sides being exactly the same, the two are going to be proportional. So if the sides are proportional that are on either side of an angle that is congruent, then we have side angle side congruency. And then the side similarity theorem says that if all of the corresponding sides are proportional, then the two triangles are similar. So side similarity, okay, which is different from congruent. So the sides are not congruent, but they are proportional. So if we want to check and see if these two triangles are similar, then we need to set up an extended proportion. So we're going to have 3 ratios where we compare all of the sides of our triangles. So my first ratio is going to be the smallest two sides, so ST 6 to VX, which is 9. Then let's go with the middle numbers, so 8 to 12. And then last, our largest numbers, 10 to 15. Okay, and you have to go in the same order. So I went smaller triangle to larger triangle each time. 6 to 9, 8 to 12, 10 to 15. Now we have to see if these match. So we have to see if they will reduce to all of the same number. If we reduce 6 over 9, we get 2/3. If we reduce 8 over 12, so divide both by 4, we get 2/3 also. So I divided those two by 4. The 6 and 9 I divided by 3. If we divide both of these by 5, we get 2/3 again. So they all reduce to the same fraction. So yes, they are similar. So we need a similarity statement. So triangle STU is similar to triangle XVW by side similarity. All the sides are proportional, so yes, they are similar. Okay, so this next one we're going to come back to together, so leave it blank for now. Okay, last we need to talk about indirect measurement. So indirect measurement is a way of measuring objects that are difficult to measure directly, like the height of a building, or the height of a tree, or the height of a statue. So here's our next problem. Before rock climbing, Darius wants to know how high he will climb. He places a mirror on the ground, so here's his mirror on the ground, and walks backwards until he can see the top of the cliff in the mirror. So he's walking backwards until his eyes can see the top of the cliff in the mirror. What is the height of the cliff? So we're looking for X over here. So we know he walked backwards 6 feet, and his mirror is 34 feet from the base of the cliff. And we know Darius is 5.5 feet tall. So we're going to set up a proportion, and the key is that we just need to go in the order when we're setting up our ratios. So I'm going to take the height of Darius, 5.5, over the distance he is from the mirror, so over 6. Okay. And both of these are in feet. So that means I need the height of the cliff. Since I had the height of Darius on the top, I need the height of the cliff on top over the distance of the cliff from the mirror. So over distance from the mirror goes on the bottom. Okay, and then since all are in feet, our final answer will be in feet, and we don't have to worry about changing any labels. Now we cross multiply. 6 times x is 6x equals 34 times 5.5, which is 187. Then we divide both sides by 6, and x equals about 31.2 feet. Okay, so we're rounding, but that is close enough. So the cliff is about 31.2 feet high.